Now we're going to get into some fun stuff. The time value of money. This is one of the really important concepts of finance, and something you can use as if you take a career in finance or just even in your personal life. Now, think about this. Would you loan out $1,000 today and then want just $1,000 10 years from now? Of course not. And we've talked about some of these a little bit, right? $1,000 today won't buy you as much in the future because of inflation. Also, you're giving up the opportunity. There's an opportunity cost. You're giving up the opportunity to use that money today and forego that for 10 years. So you're going to want something in return. Now, these happen all the time. Take the lottery. If you've ever looked at the lottery, you get two choices. You get a cash option, give me the money now, or spread it out over 20 years or 25 years. Right? You have a choice. How do you make those decisions? There's a time value associated with the money that comes 25 years out from now. You may not have thought about it, but getting a mortgage on a house. You get money today, but you pay out over time. Well, particularly from the viewpoint of the bank, what are they doing? They're giving up money today, and they expect money over a period of time. Any kind of banking. Right? They borrow money short term and lend long term. So there's lots of examples like this. And we want to know those trade-offs. We'll get into things like bonds, for example. All right. Now remember, the interest that we're going to require to give this money up is the cost of money. All right. So we're just going to start with the future value. Let's suppose I have some money today. What would it be worth in the future? Well, I typically invest it with some interest rate, and that interest rate compounds. And what we mean by that is, let's suppose you get 5% interest. You invest $100 and you get 5% interest. Well, next year you'll have $105. If you keep that in again, you get 5% on that. So you'll have more than $110. I can't do it in my head, right? But you'll get more than $110. And that number goes up and it grows and grows. Einstein called compound interest the most powerful force in the universe. It grows exponentially. It really is pretty cool. Maybe you've read in high school or sometime the book Ender's Game. Well, there's a bunch of follow-on books to that. They're really quite good, by Orson Scott Card, all about Ender. And it turns out that Ender kind of travels at the speed of light, and he's gone for like 1,000 years, which is, or something, I'm making a number up, but let's say 1,000 years or 500 years into the future. Well, the money he had invested has grown astronomically. He can buy whole planets with the money that he's got because of compound interest. All right, calculating future value. So how do we know what that money is going to look like? Well, if you use a calculator, and there are financial calculators, or you use Excel, two important things to remember. You want to have both a positive number and a negative number when you enter in the formulas. That's so that the computer can actually do a calculation. It needs a positive number and a negative number. Well, what does that mean? The thing that you can do, and the way I approach these, is that anytime in a formula I am using I have a number which represents money I'm paying out, money that's it's going away, I use a negative number. Money that's coming in, I use a positive number. Okay? And you'll see me adhere to that. And if I forget, or if you forget, if you use only positive numbers, you'll get an error. one of the first things to look for is, do you have negative numbers in there? All right, and you need to be consistent, right? You just can't randomly put positive and negative numbers. So let's take a look at an example. Here with Excel, I'm going to put $1,000 in today, and I'm going to add $100 every year for 15 years. Assume if I can get 5%, how much will I have in the future? So here's a full-blown future value problem. I take the future in Excel, I put equals FV, and then the rate. In this case, 5%. And notice I represent it as a decimal. Get in the habit of doing that. Number of periods, 15 years. We'll come back to why it says periods and not years. But number of periods. Payment. These are the annual, or the payments in every period that you make. So I'm making $100. So I'm paying in $100. That's money going out of my pocket. And PV is the present value. That's the money I have today. Well, I'm going to put in $1,000 today. If I wasn't putting any money in today, this number would be 0. If I just started contributing $100 and wanted to know that. But if I started with $100 and at $1,000 and added $100, this is what it would look like. Again, this is an optional thing. You don't have to put this in, but it represents your initial payment. The result will show up as a positive number. I put negative numbers, means I will get back $4,000 and $4,236. Okay? If these numbers were put in positive, this number would come out negative. In other words, if somebody gave me this money, I could flip this thing around. How much would you pay for somebody to give you $1,000 today and give you $100 every year for 15 years? Well, you would be willing to pay $4,236 for that. I hope that wasn't too confusing. All right. I'll continue in the next one with in the next video with the other ways we might want to look at this problem and the time value of money.